So we're finishing section 9.1, adding and subtracting rational expressions, working with some real-world examples. We're trying to find the total time in terms of the distance that this train is traveling. So we found the common denominator would end up being 120, the 30 times 40. So the first term we multiplied by 40 over 40, second term multiplied by 30 over 30. So get d times 40 plus d times 30 over the common denominator of 120. So adding in the numerator, we'll end up with 70d over 120, which we can simplify then to, 1200, 2 zeros there. 70d over 1200, which will simplify to 7 over 120d. Hiker averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip when walking uphill. Find the total time in terms of d, and then use the formula t equals d over r. So this is a similar problem to the last one. So our total time is going to be our distance that we don't know yet, d over the time. The rate. The first rate was 1.4, and then the distance and the return rate was 0.8. So we'll do a similar thing. We'll have to multiply by the common denominator. So in this case, we'll multiply by 0.8 over 0.8. And the second term will multiply by 1.4 over 1.4. So this will get us 0.8d plus 1.4d over 1.12. So that ends up with 2.2 over 1.12d, which if you plug it into a calculator, put it into a fraction, you get 55 over 28d. So that's our total time in terms of the distance d. Yvette ran an average speed of 6.2 feet per second during the first 2 laps of a race and an average of 7.75 feet per second during the second 2 laps of the race. Find her total time in terms of d, the distance around the race course. So same situation. However, this time her distance is, she did 2 laps each time. So we'll have 2 times the distance over the first rate of 6.2 plus 2 times the distance over her second rate of 7.75. So we'll have 2d times the 7.75 plus the 2d times the 6.2, all that over our common denominator of the 6.2 times the 7.75. Add those together, you'll end up with 27.9d over 48.05. Plugging that into your calculator, you'll get 18 over 31d. So last thing we want to talk about, a couple things here. Why do rational expressions have excluded values? Because you might have domain issues in the original expressions. Anytime you are possibly dividing by 0, you're going to have a domain issue. So you got to check those out at the beginning before you do anything else. Before you change anything, before you simplify anything, those domain issues are coming from the original equations. Then how can you tell if your answer is written in simplest form? When none of the factors in the denominator are in the numerator. That means we can't do any more canceling or dividing out once anything in the denominator is no longer in numerator. I'm not going to deal with that one. So this is the end of the video.